Welcome back. Today we're going to be doing lesson 1.2 out of your math journal. So you're going to need to pull page 19 and page 16 out of your math journal. We will be adding to our vocabulary. So pull it out and put it back in correctly when we're done. All right, so this is lesson 1.2. We are talking about prime factorization. I will be able to, this is going to be correctly, identify the difference between prime and composite numbers. I will also be able to find the prime factorization of any number using a factor tree or a ladder. All right, so let's take our page 16 and we're going to talk about some different words. I forgot to put one in here. We're going to add divisible. So let's write the word divisible. Okay, so our vocabulary for today is going to be divisible, factor, prime number, composite number, and prime factorization. So here's page 16. We filled some of it out yesterday. Okay, the first word we're going to do is divisible. So it's when a given number divides evenly, meaning no leftovers, no remainder, into another, leaving no remainder or decimal. Definition of divisible. So if it goes evenly into numbers. So example, 18 is divisible by 3. We got 6 out and there was no remainder. If I were to take 18 and divide it by 4, it won't go in perfectly with no remainder. Okay, factors are the numbers that are multiplied together. So if you have a times problem like 3 times 4 equals 12, 3 and 4 are factors of 12. Okay? A prime number is a number that is by only one and itself. So we're talking about numbers that if I divide them by anything, it can only divide by 1 and by itself. No other number goes into it. They're the building blocks of our number system. So let's go through, let's start at 1. So if I start at 1, we're listing some examples here. Is 1 divisible by 1? Yep. And itself? There's a little problem with that because 1 is itself. 1 is technically not a prime number. It's considered identity. So let's move on to 2. Can I divide 2 by 1? Yep. Can I divide 2 by itself? Yeah, I can divide 2 by 2. Can I divide 2 by any other number? No. So 2 is a prime number. How about 3? If I divide 3 by 1, yep, because I can divide any number by 1. I can divide 3 by itself, but is there anything else that I can divide into 3? Nope, so 3 is considered a prime number. How about 4? 4 is not a prime number. So because I can divide 1 by 4, I can divide it by 4 and by 1. But what's another number that I can divide into 4 evenly? 2. 2 goes into 4. So because of that, 4 is not. So the next prime, so I want you to write 4 here. We're going to cross it out. It doesn't work. So 5, 1, and 5 divide into 5. Is there anything else that divides into 5? No, so 5 is prime. How about 6? I can divide it by 1 and 6. Is there anything else? Yes, 2 and 3 both go into 6, so those don't work. 7, I can divide it by 1, I can divide it by 7. Is there anything else that divides into 7? Nope, so 7 is prime. Okay, let's try 8. I can divide it by 1 and 8. Is there any other number that will divide into 8 evenly? 2 and 4 both go into it also. So it's not only divisible by 1 and itself, so 8 is not. Are you noticing a pattern here? We're crossing off all the even numbers so far, except 2. 2 is actually the only even prime number, because after that, every even number is divisible by 2. So what about 9? I can divide it by 1. I can divide it by itself, which is 9. Is there anything else that divides into 9? Don't be fooled. 3 goes into 9 as well, so 9 is not a prime number. 10? Well, 10's even. 2's going to go into it, so that would not be a prime number. How about 11? I can divide by 1, and I can divide by 11. Is there anything else that goes into 11? Not evenly, so 11 is prime. So 2 is the only even prime number. Every other prime number is going to be odd, but it's not all odd numbers. See, 9 was not a prime number. So on our page, we're going to list the first few prime numbers together, but I wanted you to get an idea of what made a prime number and what did not. Okay, now we're going to talk about the opposite. It's a composite number. So if a prime number is only divisible by 1 and itself, a composite number is a number that is divisible by 3 or more numbers. So a number that is divisible by 3 or more numbers. So think of 4. We could divide 4 by 1, by 4, but we could also divide it by 2. So that gave it 3 factors. That's why 4 would be considered a composite. Okay, multiplying two or more prime numbers together. So some examples of composite numbers are 4, 6, 8, 9, 10, and the list goes on. All right, prime factorization. The prime factors, the prime factor combination for a given number. This is what we're going to focus on today's lesson. So we'll go more there, but there's your definition. So let's go back to page 19. And it says list the first 12 prime numbers. Okay, we've already listed some of them. So starting with 2, remember we discussed 1 was not prime. because it was only divisible by one number total. So it's 2, then 3, 5, 7. Odd numbers, it'll be easier. So 9, remember we decided wasn't because it was divisible by 3, but then 11 was. Okay, what do you think about the next odd number, 13? Can you think of any number that will divide evenly into 13? Besides 1 and 13. Nope, 13 is considered prime. How about 15? Oh, 3 can go into 15 and 5 can go into 15. So 15 is not a prime number. Don't be writing it down. How about 17? 1 and 17 are its only factors, so 17 is a prime number. How about 19? Only divisible by 1 and 19. 21? Probably fooled a couple of you. Remember, 21 is divisible by 3 and 7. 3 times 7 is 21. So 21 is not prime. So how about the next odd number? 23 is prime. I can only divide it by 1 and 23. 25. Oh, that one's divisible by 5. 5 times 5. So 25 is not prime. How about 27? Oh, probably caught some of you again. You can divide that by 3 and 9. How about 29? 29 is a prime number. How about 31? Nope, 31 is prime as well. 33? Oh, we can divide 33 by 3. Don't be writing that one down. 35. Oh, that ends in 5, so it's divisible by 5. So 35 won't work. How about 37? 37 is prime. And there's more, so ... there. There are more, but these are probably going to be the most common ones we're going to work with. All right, now let's learn how to make a factor tree. So it says, using factor trees, create 3 different ways to prime factorize 24. All right, a factor tree, all you need to do is make 2 branches. And I want you to come up with any multiplication way to create 24. So what 2 factors can I multiply together to make 24? Okay, the first one that comes to my mind, and this might not be yours, but we will cover it. The first one that comes to my mind is 6 and 4. Okay, now when you are making a factor tree, anytime you write down a composite number, you're going to break it down again. Anytime you write down a prime number, you're going to circle it. So is 6 prime? Nope, 6 is not prime, so keep on breaking it down. So 6, what makes up 6? What times what? 2 times 3. Is 2 a prime number? It is, so circle it. Is 3 a prime number? Okay, circle it. Okay, to end a branch of the factor tree, it has to end in a prime number. So is 4 prime? Nope, so we're going to break it down some more. What times what can give me 4? 2 times 2. 2 is prime and 2 is prime. Now, see how every branch ends in a prime number? That tells me we are done. So, let's try it a different way. What is a different set of factors that I can multiply besides 6 and 4 to make 24? Okay, the next one that comes to my mind is 8 times 3. Now, I want you to realize, don't be doing 24 and 1. That doesn't help you get anywhere. 1's not prime, and then you're just going to break down 24 again. So avoid anything that's just something times itself. So 8 times 3 is 24. 3 is prime, so I'm going to circle it, but 8 is not. Now what times what could give me 8? 2 times 4 could give me 8. 2 is a prime number. 4 is not, so I'm going to keep going. So let's break down 4. We get 2 and 2. 2 times 2 is 4. Now, every branch of this tree ends in a prime number. That tells me I am done. Let's try this one over here. another way we could multiply and get 24. I could do 2 times 12. Okay, 2 is prime, 12 is not. What times what can give me 12? There's a couple ways you could do this one. I'm going to do 3 and 4. If you did 2 and 6, it would still work out. You just keep breaking it down. So 3 is a prime number, 4 is not, so I'm going to break it down some more. So 2 times 2 gives me 4. Now see how every branch ends in a prime number again? Okay, we have 3 different factor trees. But in the end, I want you to notice something. I have 1, 2, 3 2s and a 3. 1, 2, 3 2s and a 3. 1, 2, 3 2s and a 3. So no matter how you break it down, we just did 3 different factor trees for the same number. But no matter what we found the recipe to build this composite number. The prime factorization of any number will always be the same. So we're going to write the prime factorization, which would be 2 times 2 times 2 times 3. And we like to list it lowest to biggest so we don't miss anything. So that's why I'm listing the 2's first and then the 3. Okay, that's all there is to prime factorization. Now I'm going to show you another way to look at prime factorization. We're going to use a factor tree and then we're going to try the ladder. So factor tree here. 2 things that multiply to give me 320. Okay, easy one, it ends in 0, so I know 10 times something is going to give me 320. 10 times what? 32. So even if it's not a small number that you automatically know, like 24, you can break it down. We know it's an even number. I could just divide by 2 if I wanted. Remember, there's multiple trees. As long as you're dividing by a number that really does go into it, all trees will lead to the same ending. Now, 10 and 32. Can I break down 10 anymore? I can. It's a composite number, and it's made up of 2 times 5. 2 is prime, and 5 is prime. So I am done with this part of the tree. 32, I can break down. 32 can be made by doing 2 times 16. Or you could have done 8 times 4. Both would work. 2 is prime. 16 is not. I'm going to break it down. I know 16 is 4 times 4. Or you could have done 2 times 8. 4 is not prime, so I'm going to break it down. 2 and 2. 4 is not prime, so 2 and 2. Okay, every single branch ends in a prime factor, so I am done. So the prime factorization is going to be 2 times 2, I just don't want to skip one, times 2 times 2, times 2 times 2, so there are 6 2's here, and a 5. That is how you make 320 out of prime numbers. Okay, I want you to also be able to do a ladder. So a ladder, you want to draw kind of like an upside down division box. And then what I like to do is I like to just start with, it's easy for me to divide by 2. So you're going to write a 2 out here. So whatever you write on this side is going to be a prime number. I know 2 goes into 320. Half of that would be 160. And I keep going with that prime number until it won't work anymore. So 2 I know goes into 160. So half of 160 is 80. Put another 2 because I know 2 goes into 80. Divide 80 by 2, I get 40. And notice how I'm just keep going on with the 2's. 2 I know goes into 40, so I'm going to write half of that, which would be 20. I know 2 will go into it again. 2 goes into 20. That'll give me 10. 2 goes into 10 5 times. Okay, and now what goes into 5? Because this is prime, I know that I am done. So these are all my prime factors. So I have 1, 2, 3, 4, 5, 6 2's and 1 5. So when I get down to a prime number here, the rest of these are also my prime factors. If you ever keep going, but you can divide by 3, then you can start with 3's. This one just happened to work out that all of these 2's went into it till I got to a prime number. Okay, one little example. I want you to try 96 with me over here. Okay, so let's do a ladder on 96, just for a little practice. So it's an even number, so I'm going to do divide by 2. So 2 goes into 96. I know that 2 goes into 48. That gives me 24. Okay, as long as whatever is out here is prime, you can put it in. Oh, I know 3 goes into 24. 3 is a prime number, so I'm going to put a 3 here. 3 goes into 24 8 times. And what goes into 8? Oh, 2 is a prime number. 2 will go into 8. So that would give me 4. I know 2 will go into 4. And that gives me a 2. Now that this at the bottom is a prime number, I know I'm done. So my prime factorization of 96 would equal 2 times 2 times 2 times, let's see, 1, 2, 3, 4, 5 times 3. Okay, so that's how to use a ladder method or a factor tree. Both work. You use whichever one you prefer. Now, I want you to rate yourself on this concept. 0, 1, 2, 3, or 4. 4 meaning I have this and I don't need any help. 0 meaning I still have no idea what we're doing, but I'm willing to work and try.